Gianna and Galvin, you as well, बच्चों. Gianna, your screen is basically your video is not coming to me. Please check your camera, dear. It's a black screen at my end.
Sir,
Yes, Gianna.
sir, I'm in India, so the connection
अच्छा,
is a little low.
okay. ठीक है, no issues, no issues. ठीक है,
Thank you, sir.
okay. Gianna, you are also from Kerala?
Yes, sir.
अच्छा, ठीक है. Hello, Aisha. Assalamu alaikum. How are you, बच्चे?
Walaikum assalam, sir. Alhamdulillah, fine. What about you?
I'm good, dear. I'm good. Thanks so much for asking. Okay, so just let me check that whether others are joining or not. Please switch on your camera, Aisha. Galvin, US will बच्चे क्या हुआ? This last class में we have started atmospheric refraction, right? We have also completed, like we have completed the twinkling of stars and what I was saying, why planets do not twinkle, right? This was the question of why planets do not twinkle. At least say yes or no. कुछ तो बोलो. Gianna, were you there in the last class? Galvin, Aisha, were you there in the last class?
Yes, sir.
Okay, so you were there. So please at least say yes or no. Okay, so this let me check. Okay, so in the last class, there was an assessment as well. So let me check who has given it. Okay, Harshit gave it, Galvin gave it, Aisha gave it. Aisha, that's very good. You got 100%. That's a very good number. Same with Maha, Sumaya, Maharaya. Sure, that's good. Harshit and Galvin seems a little bit disappointing. What happens? Were you confused in atmospheric refraction? Oh, sorry, dispersion of light? Hmm? Just a moment, let me check. Okay, okay, so let's start with the class. Okay. Okay. So at this point, we have completed the the first application of the atmospheric refraction, that was the twinkling of stars. Okay, now let's talk about the second one, that is the advanced sunrise and delayed sunset. Okay, so the second is, okay, advanced sunrise and delayed sunset. Okay, so just a second, let me show the picture once. Just a minute, let me show the picture to you. Basically, what is it mean? देखो. So as you can see that this is a sunrise position. ठीक है? So what happened is that in actual, it is the horizon is the line which basically separates the sky and the ground. It seems like when you basically see a very far plane line, what you see is that basically at a certain point the ground and the sky basically they seems like they have a very basic common line between them, right? Have you seen this? Like when you basically travel in a ship, or you will feel like when you're traveling in the ocean, you will feel that when you basically very far from your ship, there is a line basically at point where the sky and the ocean appears to meet. That line is called horizon. In actually, this is not an actual line. Basically, it's just the you can say visualization that is your sky and the ground is going to meet, but in reality, it's not going to happen, but it seems like it, right? So you can see this horizon is the point, okay? And the actual position of the sun is below the horizon, but due to the atmospheric refraction, it seems like the sun is above the horizon, right? So this is called advanced sunrise. Same here in the delayed census point, what happens is that basically it seems like in actual, the sun is below the horizon, but due to the atmospheric refraction, the sun appears to be above the horizon. That's why we see 4 minutes of, you can say, delay. You can say delayed in the actual length of the day. Okay, so just a second. Okay, the sun is visible as about 2 minutes before and before the actual sunrise and 2 minutes after the actual sunset. Okay. Because of atmospheric refraction. Hello Rayan, Assalamu alaikum. Okay. So this is the reason. Clear everyone? At least say yes or no. कुछ तो बोलो.
Yes.
Okay. So basically, this happens due to the atmospheric refraction. The sun appears to be up, you can say, raised in the morning, and it appears to be, you can say, it appears to be delayed sunset in the evening. Okay, due to the atmospheric refraction. Clear, everyone?
Yes, sir.
So let me write down the reason of that. Ryan, am I audible, dear? Still connected. Yes, audible. Check. Okay, so basically. When the sunrise, when the sun is slightly below the horizon, then sun's light coming from less dense air to more dense air. Is refracted towards the refracted downwards as it passes through the atmosphere. Check it. Clear, everyone? At least say yes or no. कुछ तो बोलो.
Yes, sir.
Okay. In the actually, it's below the horizon, but it's coming from the less dense air towards the more dense air. Okay. And due to that, the refraction occurs in the downwards position. So that's why it appears to be upraised. Okay. Because of this atmospheric refraction. The sun appears to be raised. Above the horizon. Clear, everyone? Please let me know once if it's clear to you. Aisha, Gianna, Galvin, Harshit,
Yes, sir.
and Rayan still connected.
Yes, sir.
Sure, ठीक है, that's good. ठीक है. So above the horizon. ठीक है. And due to that, we see the delay in the sunset and advancement in the sunrise. Clear? Sure. C point is the time from sunrise to sunset is lengthened by about 2 plus 2, 4 minutes. ठीक है? Because of this atmospheric reflection. Please let me know, everyone, is this clear to you or not?
Yes, sir.
Sure, everyone? Galvin, Gianna, Aisha, Harshit?
Yes, sir.
Sure.
Yeah.
Okay. So this is the case of the atmospheric refraction. Clear, everyone? Okay. So these are the two cases that can be there in your school's exams. Okay. So after this class, you will be having an assessment. Okay. So go and check out the assessment as well. Clear, everyone? Do not miss the assessment, okay, at any cost. Okay, please write it down and let me know. And then we'll start the new topic, that is dispersion of light. Dispersion of, so not dispersion, it's scattering of light. Hello, Riyan. Assalamu alaikum.
Yes, sir.
Where were you, dear, in the last two classes?
Last class?
Last class, yes. You were not there in the last class, Riyan. Just to check. Just let me check. I think you were not there.
So can you tell me the date?
Let me check. Let me check. Why did you
So
join so
now,
late,
sir, I
dear?
was in Masjid, sir. Now I was
अच्छा
in Masjid, sir.
अच्छा
Actually,
अच्छा
our prayer time is like different, sir. Like at
अच्छा
4 o'clock.
okay. So just a second, let me check the attendance of yours in the last class. Rayan, you were present, not you were not present in the last class, 11th July,
So
and
Thursday,
yeah, Thursday, last Thursday, yes. And if you talk about the 4th of July, last to last Thursday, there's some issue
sir.
while loading the attendance. हाँ बोलो yes.
I guess, sir, on
Yeah.
the first that day,
हम्म
I guess, sir, we went to India, sir. I guess
अच्छा ठीक है. Okay, so
on that
but
day. I don't remember the day.
so do not miss the classes, Rayan here, please. Okay, so please be
Yes.
regular in the class. ठीक है? Sure. Okay, so I've basically completed this topic. So okay, what you will do is that in this right now I'm going to start a new topic, that is scattering of light. So from the next after this class, go and check out the recording of previous classes. Riyan. ठीक है? Okay, Riyan? Sure.
Okay, sir.
Sure. Okay. So everyone done with the writing? At least say yes or no. कुछ तो बोलो. Harshit, Aisha, Gianna, Galvin.
Yes.
Yes, sir.
Yes, sir.
Sure. Okay, now let's start a new topic or the last topic of this chapter, that is scattering. What does it mean, scattering?
Ma'am, sir, actually the scattering of the light into a many,
Yes, Harshit, you were saying many,
sir, like in many, basically light can be scattered into many colors. That is what it.
many colors. Many colors. What is the difference between dispersion? Yes, Harshit.
Sir, I think the same thing is the dispersion.
No,
Uh,
that this is different, Harshit. This is different. Just a second. Okay, so let's start a new topic. Okay. Just checking something. Okay, so basically, let me tell you what does it mean, scattering. Scattering word means it's like you can say spilling out everywhere. Yeah, like basically, what you will do is in terms of, suppose that you have a glass of water and you basically just throw that glass of water like this. So what will happen? It basically spill out in maximum area, right? So if we talk about the scattering of light in terms of the light chapter, that means that throwing the light in various random direction. It means that light will spread out in the very random direction here without any proper path. Clear, बच्चों? Say yes or no, कुछ तो बोलो.
yes, sir.
ठीक है? Yeah. So that is what scattering. ठीक है? And scattering depends on the wavelength. The most important thing about wave scattering is it depends on the wavelength. Okay, so now we will discuss the you can say some more applications like why the sky appears blue, why the sky appears red in the sunset and sunrise, and what is Tyndall effect. Okay, so these are the things that we will discuss. Clear, everyone?
Yes.
Okay, and we'll also discuss that why outer space appears to black. Like why, like if our atmosphere appears appears blue, why there is blue color in the outer space, why it's black. Okay, so we'll discuss that thing as well. Okay, so now first of all, let's write down the thing about the scattering of light. So just a moment, actually my pen is not working. Is it moving? My pen is moving. Is the cursor moving at your end? Please let me know once.
Yes, sir.
Chalo,
Yes, sir.
chalo. Okay, so let's write down about the point of scattering of light. Okay. So A point. So scattering of light is the phenomena by which a beam of light is redirected in many different directions when it interacts with a particle available in the atmosphere. Okay. So this is scattering of light. Clear, everyone?
Yes.
Sure. Okay. So now let's discuss some properties of scattering of light. Okay. So the most important thing about the scattering of light, it depends on the wavelength of the color. Okay. Wavelength means how much distance it will cover in one oscillation. Okay. wavelength of sorry. Okay. Okay, clear everyone? So now let's talk about the Tyndall effect first. The first application of scattering of light is Tyndall effect. Have you heard this word before? Tyndall effect, bacho?
Yes, sir.
Anybody knows what it is basically?
Sir, the light passing through milk.
Passing through milk? Acha, ठीक है.
Sir, in a solution which is like any stable solution which
A solution, ठीक है.
and so there are like real life examples of Tyndall effect too, in a light in a forest, in a dense forest.
Okay, ठीक है. ठीक है. Yeah, so basically Tyndall effect is the basically scattering of light by the particle in its path. You must have seen that when you are basically entering a black room and suppose there is a very small hole, you will see that the light will basically light is passing through that hole, light is coming from that hole, and you will see that some particles are suspended in the air. Have you seen this thing in a very dark room and only a very small hole is opened? Have you seen this? Hello, Bucho. Have you seen this? Look, let me tell you. How does it look? So in the forest, the example given is very similar to that I've given you about the room. So in the forest, you must see in a very dense forest, you must have seen that there is very low lighting, but the light basically coming from the bushes, the space available there, you will see that in this light coming, basically some air particles will be suspended, dust particles like this. Okay. So this is basically observed in a very dark room or in a very dense forest. Okay. So let me tell you what is basically Tyndall effect. Tyndall effect. Sorry, scattering. Scattering of light by particles in its path. Rayan, what happened? Seems a little bit distraction at your end. Please focus on the screen, Rayan. Okay. Tyndall. Okay. So Tyndall effect basically is a process in which basically two factors are very important. The first is the size of particles, okay, basically that are scattering the light. Second is the you can say the wavelength of the light. Okay, so let me tell you. S B. Tyndall effect. Can be discovered at when that white light consisting of 7 colors is passed through a clear liquid having small suspended particles in it. And it okay. So what you will observe in that blue color is scattered most because of having shorter wavelength, and the red color will scattered least because having longer wavelength. Okay. The blue color of white light having shorter wavelength scattered more than the red color having long. So red color will be scattered least because of the longer wavelength. Clear, everyone? Please let me know. Is this clear to all of you?
No, sir, I think you said that like longer wavelength scattered the most.
No, I didn't say when. No, I
No,
said the when. Tell me, Harshit, when?
like longer wavelength scattered the most. So
Longer wavelength scattered least. Okay, so are you taking the reference of dispersion?
yes, sir.
No, Harshit, this is different. Dispersion is different. This is even dispersion. The deviation is least when the color is red. The deviation is the maximum when the color is violet. Don't mix it up. It's completely different. Okay?
Okay, sir.
Yeah. So now let's do the next part. Okay. Now let's understand what are the factors that affects the scattering of the light. Okay. So scattered light depends on the two factors. First is the size of the particle. Second is the wavelength. Okay. So let me write it down. C, D. The color, the scattered light, depends on the size of scattering particles in this. Okay. The atmosphere. Clear, everyone? So the first is what you will,
Yes, sir.
this larger so what you will observe that the larger particle of dust and water droplets. Rayan, what are you looking at there? Are you doing something else?
Yes, sir.
Are you doing something else apart from the studies in the class?
No, sir.
So why are you looking at somewhere else?
No, sir. Actually, this is my webcam, sir.
Acha, this is your webcam. ठीक है, ठीक है.
The down,
At
this is webcam, sir.
ठीक है, चलो,
See,
ठीक
sir,
है.
it's
Okay. Scatter the light. Okay. So the large particles of dust and water droplets will scatter the light such as due to which the scattered light appears white. It seems like they will not scatter it like in such a manner that they split, they basically have different colors, but due to in the contrast of it, it basically scattered it, the light that is scattered, it appears white. Clear, everyone? The large particle scatters the light in such a manner that the scattered light appears white. Okay. Sorry. Second part is the extremely minute particles. This is not minute, this is minute. Minute means very small. Okay. Such as air molecules. Okay, present in the atmosphere, scatter Mainly the blue light of light present in. I'm just taking a 1 minute pause because it's azan right now. Okay. Then okay, thanks so much for waiting, Mucha. So now let's start it again. So mainly the okay. So the extremely minute particles will mainly scatter the blue color light in the white light. Okay. And the large particles will scatter the light such as it will not such it will basically scattered as a white light. Okay, because you can say the large particles will not scatter the individual color. It will scatter the white light as it is. Okay. Is this clear to all of you? Please let me know once. Harshit, Gianna, Aisha, Galvin, Rayan. Clear?
Yes, sir.
ठीक.
Yes, sir.
Okay, so Harshit, now you can tell me the doubt of yours and we will solve it together. Okay.
So it is the 15th question.
15th question. Let me check your
Sir,
question
actually want
paper.
to ask like what figure should be made over there?
15th question. Look at the table. Identify. Is this one?
No, sir, actually the below.
The power of a lens.
Yes, sir, that.
Okay, so just a second. The power of a lens is plus 4D and distance of 15 from the optical center. State the nature magnification of the image formed by the lens and draw a ray diagram to justify your answer. अच्छा ठीक है चलो let me draw it then. ठीक है. So in today's class, we will take the scattering of light till this point. Okay. The next class, we will do some more conceptual question based on the, you can say, scattering of light. Okay. So question is saying कि power of a lens is 4D. Okay. I'm writing all the things that is given. So question is, okay, power of a lens is plus 4D. Okay. And find the focal length of the lens. तो हमें focal length चाहिए. We need focal length. Okay. An object is placed at 50 centimeter from the optical center. So object distance is given to you as minus 50 centimeter. Okay. State the nature and magnification. Okay. So देखो, you have given the focal length. So power is equals to the inverse of focal length. Okay. If the focal length is in centimeter, because we need focal length in centimeter because object distance is in centimeter. So F will be equals to 100 by 4 centimeter. So ये हो जाएगा 25 times. ठीक है. So 25 is your focal length. Clear, Harshit? Everyone?
Yes, sir.
ठीक है. Sure. Now let's do the apply the lens formula, that is 1 by V minus U is equals to 1 by F. ठीक है. Substitute the value. So 1 by 25 is equals to 1 by V minus of minus 1 by 50. ठीक है. So it is 1 by 25 is equals to 1 by V plus के 1 by 50. ठीक है. So 1 by V would be 1 by 25 minus 1 by 50. ठीक है. So ये हो जाएगा क्रॉस मल्टीप्लाई देम 25 into 50. So ये हो जाएगा 50 minus 25. So it is coming out to be 25 by 25 into 50. रुको यार, did I make any mistake? नहीं, ठीक है. एक बार क्वेश्चन देख लो. Is object is placed at a distance of 50 centimeter from the optical center of the lens. ठीक है. और power of lens is 4 है. ठीक है. 4 हो गया. 25 से 4 ठीक है. V focal length ठीक है. और 150 हम उधर भेजेंगे तो minus 1 by 50 50 minus 25 ठीक है. ठीक है. सो ये कैंसिल हो जाएगा. तो ये आ जाएगा V आ गया आपका 50 सेंटी. सो V आपका 50 सेंटीमीटर आ रहा है. क्लियर?
Yes,
सो
sir.
अब इसमें जो इमेज बनेगी वो बनेगी ऐसे, बिकॉज देखो पावर इज पॉजिटिव, सो ये इट्स अ कन्वेक्स लेंस. ठीक है. सो यू कैन सी दिस थिंग. सो ऑब्जेक्ट ये हम ले लेते हैं. ये फोकल लेंथ आपकी 25 है. सॉरी, फोकल लेंथ आपकी 25 है. ठीक है. एंड ये 50 है. You can see this thing, everyone, that image distance and object distance are same. Only the sign is basically saying the image object is placed on the left hand side, the image is formed on the right hand side. Okay, so that's why it is positive, that's why it is negative. So what will happen, देखो, so image is formed at, so object is formed at, placed at 50 centimeter. This 25 centimeter ये minus लगा दो आप शायद. ठीक है. So you can see this thing, Harshit. This is the image. It means that object is placed at the center of curve, the 2F1. ठीक है. and it will pass through the focus first line, and the second line will pass through the optical center to make an image on the ठीक है अर्षित, ये इमेज आपकी बनेगी सेम साइज की। थोड़ा सा मैं इसको एडजस्ट कर देता हूँ तो मैं थोड़ा सा